Hello friends, I am Saroj Vishwas, gold medalist, first rank holder of 1994 batch in engineering stream of all the colleges affiliated to University of Mysore during that period. A BE in civil engineering from National Institute of Engineering Mysore, a MTech in structural engineering from Indian Institute of Technology, Delhi, that is IIT Delhi, a Sun certified Java programmer, Sun Microsystem USA. I have more than 25 years of professional experience in designing building structures and allied subsidiaries. I invite you all to learn with me how to design building structures using commercially available structural softwares with the help of some manual computation as and when needed. In this section, we shall learn how to provide the cross-section elevation data to the structural general arrangement drawing detailer so that he is able to prepare the structural general arrangement drawing, that is called structural GA. So this is our STAAD file in which we are working. So if you go to level, structure, full section, fill plates, apply. Okay. This kind of 3D view will appear using the snipping tool and taking the model. If you paste this on Excel sheet, then on the Excel sheet it will look something like this. We have put the grid line also so that it is clearly comprehended by you that how the structural GA data are provided to the structural GA detailer. So in structural GA data we provide grid by grid elevations to the structural GA detailer, then the floor plans, then the roof plans, and along with that the connection details as well. So if required, we need to provide certain more elevations or sections along other parts as well. If no grids run at those parts, and section should be provided for those parts. So let us go grid by grid. Now let us go to grid A. So for grid A, if we open the corresponding section, press shift N, so notes numbers will be visible now. Now let us cut a section tool, cut section, exit plane, node number 3. So sorry, it should be XY plane. So cut section, XY plane, node number 3. So this is our section along grid A. So if we again open the full sections view or section outline, so it can be seen like this. Now let us snip this. Now first let us go to the property, then label, structure, section outline. Now let us snip the model, new section, snip the section, copy, and then paste it to Excel file. So this will be our cross section along grid A. Now first of all we have to write the member sizes, then we will go for provide whatever should be the connection details. So let us first see what is the R10. Go back to the STAAD model. R10 is 316 and 150 by 8. That means wave is 300 by 5 and flange is 150 by 60. 150 by 8. So our wave is 300 by 5 and flange is 150 by 8. We can make it somewhat bigger. So this is our column size. So let us copy this. So we have 4 such cases. So this column is something like this. This column also have same dimension. This column has also same dimension. This column has also same dimension. Now the column at the center. So it is R11. What is the dimension of R11? R11 is 350 by 5 and 175 by 10. So let us copy it, paste. So 350 by 5 and 175 by 10. The lower part also has same dimension. So then our columns, our beams at floor level. So what is it? Is R12. So let us go see it again. It is again 305 and 150 by 8. So we can use the same thing. So let us copy it, then drag it over the. Then our raptor is R14. R14 is 250 by 4 and 130 by 6. Copy, paste here. Let us change this to 250 by 4 and 130 by 6. So copy, paste. Once again, see, I am doing this in an Excel sheet because this will be used in a YouTube video, but in actual practice you should take a print of this frame after taking a snip and painting on a paste or something like that. Take a print of various grid and write it using a pen. That will be faster because this is a slower process. But if you need to provide this data to remote detailer, then you will have to follow this method only. The other method could be writing it with the help of pen and scanning it, but I feel this this kind of data will have more clarity, because in handwriting the declarer might not be able to understand at some part, and the engineer is not readily available because declarer is at remote place. So our member details are complete. Now let us look at the connections. So if you see, let us go to 3D section and label, apply, go to 3D, select non-radio. So this is a fixed connection, this is a fixed connection, this is also fixed connection, this is also fixed connection, this is also fixed. So everything is fixed. Now we for this kind of height we might not require a column splice. If needed, we can also consider a column splice at this point, say about this point, or maybe at the floor level. So, but it depends what is the transfer limit. The design of this column splice will be similar to the end plate movement connection having axial compressive force. So let us first draw the various connection and name them. Shirt shape, copy it here. So let us change the color in field. Format, shape includes, so something like this. Control C, Control V, place it here. 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 Then Control V, place it here. This will be cantilever. So this will be something like this. Control V, something like this. Control V, something like this. Control V, Control V, something like this. Control V, something like this. So you can delete this. Now if you see how I have placed this connection, see this plate I am placing. One plate is along the column flange itself. That means if the end plate is thicker than the column flange, locally for that column part we need to provide locally same thickness of the column flange. Now then additionally there will be some stiffener, so we should also draw that. So this is our stiffener. You can copy it, Control C, and paste. Take it here, there will be stiffener here. Take it here, there will be stiffener here. So accordingly, we need to provide stiffener at all the places as per requirement. Now, these are the stiffeners. Now at times the draftman may actually make this cantilever something like this. So something like this. Making the bottom flange horizontal. So as long as it is the section depth is more than R14, it is okay, and the section also remain compact or semi-compact, whatever is the category of R14. So it shall be okay. So now let us name all of these connections. So going through the Excel file, we'll see what is our movement connections. So we'll name this connection as per the Excel sheet we have designed. I have already discussed how movement connection is to be designed and shown on example. So accordingly, this various connection has to be designed. So we have connections as EP1, EP2, EP3 and EP4. So our Excel sheet has been defined for this connection and this connection as EP1. So let us name this connection as EP1. Shape EP1. Let's make it bigger and color it bit differently. So we have two such connections. Copy. So this is our EP1. Again, this is our EP1. So we have to provide the detail also. So let us open the connection design sheet. So now if we open Excel sheet, so let us open computer connection design, and then this is our movement connection EP1 grid A. So this has been already designed. So we have this detail. So what we can do, we can either sketch it or take a snip and paste in the Excel file for GA. So let us take a snip, new snip. Let us first adjust this. So snip, new snip. This is our EP1 connection. Edit, copy, then go to our detail file. This is our EP1. Let us keep it here, EP1. Then our next connection will be EP2. Let us copy this, copy, EP1, copy this, copy, paste. This is EP2. This is EP2. connection detail for EP2 is, just go to the Excel file. We have this file, open, computer connection design, EP2 grid A. So this is our EP2. Now if you see, the wave plate is here is thicker than the wave plate of the column. Locally, this shaded portion is thicker than the wave plate. So full penetration weld has to be provided at these connections. You can see this connection, copy, paste. These connections also full penetration weld making groove need to be provided. So let us take a snip again. New. This is our EP2. Edit, copy. And I can paste. So EP2. Similarly, we should name these connections. Copy. This is EP3. Put it here. Let us copy this also. Copy. Let us copy this. Copy. Copy. And paste it here. Paste. Paste. So this will be our EP4. EP4. Let us 4 such connections are there. Copy. This is our end plate type connection. 4, 4. We have to provide the detail also. Going back to the Excel file, we can have following details. So EP3 and EP4, these are 12 thick plate. You can see one is 175 mm wide, the other one is only 150 mm wide. So similarly, we can prepare detail for grid B and grid C. So you can see in the STAAD file, if you go to the STAAD file, view whole structure, properties. So they have same column and same type of beam. R19, R18, R19, R30 also same column. So we can provide a common elevation for both of these grid B and C tool. Cut section, cyclone grid 9. Obviously at grid 9 there is a landing beam here coming at mid landing level, so that can be seen in the elevation along grid 3. So hence we can provide a common elevation for both of this grid to minimize the. So let us now open in outline view, level, structure, full section outline, like so. This is our beam and columns. So let us take a snip of this. Edit, copy. So paste. Let's copy this. Paste. So this is carried along B and C. So after providing the member sizes, it will look something like this. These are our flange and wave detail. Now note this. See, this column, this beam has a getter depth here. So the pattern should be something like this. This is 350 to 250. So the wave plate is reducing from 350 mm to 250 mm at this point. And again, this point, it is at this point 250 mm. If you see, this point it is 250 mm. So this is 250. Then this point it is 350 mm. This is 350. Again, at this point, this is 250 mm. So accordingly, we have to write the wave. This is a single piece. This shall be a single piece. So during drafting, the draftman might increase a bit. That will be increase a little bit because it has to be made STAAD at this point. Now this is a single point is being provided because STAAD connection has to be provided at this point. So our wave, our beam detail here will be something like this. So this will be the flange, this will be the flange, and the STAAD will come and connect here with its end plates. So again, see, at this point this is 250 and at this point this is 350. So accordingly it has been 250 oblique 350 by 5. So this is the naming pattern. This actually helps the detailer, fabrication detailer, when this is being detailed in this pattern in the structural GA. So ultimately this structural GA will be developed, will be used to develop the production drawing, what is called your fabrication drawing. So let us now provide the connection details. So let us name all the connection first, and accordingly we will open the Excel file and provide the detail also. So after naming the connection detail and providing the details of the connection, the sheet will look something like this. So this is how the end plate connection details, as this plate along grid B and C will be seen, and note this, at this point, this is the point where the column flange is lesser width than the end plate width. So at this point the column flange has to be locally provided extra width like this. This will be a job of the fabrication detailer, but for information as an engineer you should know it. So our next section is cross section along grid D. So tool cut section XY plane, it shall be through grid number 1. So if we go to outline view of the structure, so section outline, apply. So let us take the snipping to new section. Edit, copy, and so this will be our section along grid D. After providing all the connection detail and the member sizes, it will look something like this. So cross section along section D will look something like this. Now note this. This is a hinge connection. The detailer will provide adequate thickness to make it straight. So detailer will be something like this. All the bolts are within the flanges of the columns.